Stoichiometry, it is the study of composition, chemical composition of matter and chemical calculations. Chemical calculations based on chemical reactions or chemical equations. So, this study is called stoichiometry, about composition of matter, about chemical calculations. Total study is called stoichiometry. So, before study of the composition of matter, let us see what is exactly matter. Matter, it is a part of the universe. We have total universe. It is a part of the universe having mass and occupying space, that is volume, which is under study. So, matter, it is a part of the universe, part. See, this is the total universe. In this we have a part. This part may be small or big. Maybe your pencil, it is matter. Pen, it is matter. Earth planet, it is matter. About matter, a systematic scientific study, thinking about matter done by John Dalton, and his total thinking, what we have, Dalton's atomic theory of matter. So, atomic theory of matter given by John Dalton. So, main postulates, important points about Dalton's atomic theory of matter. Matter, whether you take pen or pencil or chalk piece, whatever the thing. So, matter, it contains large number of tiny particles, very small particles, tiny particles, so called atoms. Matter contains large number of tiny particles, so called atoms, which are indivisible. Means you can ask me 1 lakh atoms, 1 million atoms, 1 billion atoms, but don't ask, sir, half atom, 0.1 atom. It is meaningless. So, atoms are indivisible. Matter containing these atoms neither created nor destroyed. And atoms of the same element, suppose hydrogen is there, wherever it is hydrogen, it exhibit same properties. Atoms of the same element exhibit same properties. Likewise, atoms of different elements, for example, hydrogen and oxygen, they are different. Hence, their properties also different. Atoms of different elements exhibit different properties. Then, atoms of different elements, for example, hydrogen and chlorine, they combine to form compound atom, that is combination of atoms, so called compound atom, example HCl. The properties of compound atom, for example HCl, are different from the constituent elements. So, HCl properties are different from H and Cl. After a systematic study by Dalton, so called atomic theory of matter, about matter, several scientists, Lavoisier, Proust, Dalton, Richter, Gilliac, Berzelius, Avogadro, they studied the composition of matter and they studied what is happening to the matter in chemical reaction. It means what is happening to the reactants which are getting converted to products, about their composition, about their mass. Their studies are so called laws of chemical combinations. Law of conservation of mass studied by Lavoisier, Antony Laurent Lavoisier. In a chemical reaction, matter is neither created nor destroyed. It means 100 grams of reactants as matter gives 100 grams of product as matter. So, before the reaction, matter is 100 grams of reactants. After the reaction, matter is 100 grams of product. Neither increase nor decrease, neither created nor destroyed. That means this 100 grams not becoming 101 grams, 100 grams not becoming 99 grams. 100 grams of reactants equals to 100 grams of products. It means in a chemical reaction, mass of the reactants equals to mass of the products. That means before the reaction and after the reaction, mass is same, hence it is said to be conserved. Mass is conserved, known as law of conservation of mass, given by Lavoisier. Law of conservation of mass is applicable to balanced chemical equations. For example, here N2 gas with H2 gas giving NH3, it is not balanced. So, here N2 1 mole 28 grams, 1 mole of hydrogen 2 grams, total mass is 30 grams. But after the reaction here NH3 17 grams. So, for this one law of conservation of mass is not applicable. It is applicable only for balanced reactions. See here 1N2, 2Ns, 2Ns, 3H2, 6Hs, 2H3, 6Hs. Equation is balanced. Here 1 mole of nitrogen 28 grams, H2 each mole is 2 grams, 3 moles of hydrogen 6 grams, 28 plus 6 totally 34 grams. After the reaction NH3 molecular weight 17. So, 1 mole is 17 grams, 2 moles 2 into 17 34 grams. Before the reaction mass of the reactants is 34 grams. After the reaction mass of the products is 34 grams. That means mass is conserved, applicable for only balanced chemical equations. Law of conservation of mass experimentally proved by Landolt. Here Landolt, by taking inverted Y-shaped tube and one corner taking aqueous solution of sodium chloride, the other corner taking aqueous solution of silver nitrate as reactants. This reactants with inverted Y tube mass is W grams. So, W grams is mass of reactants plus tube. After the reaction, so that means this tube is tilted. Once the tube is tilted, reactants they mix together and giving products AgCl and NaNO3 is the best example for double displacement, double decomposition. So, Ag combined with Cl giving a white precipitate of AgCl and NaNO3. After the reaction, tube plus products mass also W grams. Before the reaction, reactants plus tube W grams. After the reaction, products plus tube W grams. Hence, law of conservation of mass experimentally proved by Landolt, given by Lavoisier. Law of constant or definite or fixed proportions given by Proust. According to law of constant proportions, compound contains the elements in a fixed ratio by mass. For example, water contains the two elements hydrogen and oxygen. Whatever the method water is prepared, that is by combustion of hydrocarbons, say for example methane on combustion gives water, or by neutralization of acid with base the product is water, definitely contains only hydrogen and oxygen in a fixed ratio by mass, that is H2O. Actually, here its mass 2 units, O its mass 16 units and total H2O molecular weight 18. It means every 18 grams of water, whatever the method you prepare, definitely it contains 2 grams of hydrogen and 16 grams of oxygen. Hence the ratio 2:16, that is 1:8, which is a fixed one, which is constant, which is definite. So, water contains the two elements hydrogen and oxygen in 1:8 ratio by mass, given by Proust, known as law of constant or fixed or definite proportions. Likewise, in SO2, the two elements sulfur, so sulfur mass is 32 units and O2 oxygen, O atomic weight 16, 16 2s are 32. So, the ratio 32:32, that is 1:1, which is the fixed one for SO2.